Next. Yeah, I feel like I'm working at the DMV office because I'm just calling the numbers out and I'm waiting for these amino acids to come up to the counter so I can help them with their taxes or their tags that might be expired, right? So here we see amino acids. We've talked about 9 of them so far. Aliphatic side chains, hydroxy side chains, sulfur containing side chains, and now we're going on to our next kind of family of amino acids. And this family will concern the acidic ones. So these are amino acids that have acid groups on them at the end. Okay, so let's start off with our first version of an acidic amino acid. And this is a CH2 group with a C double bond O, OH. Now the problem here is that this acidic group is a carboxylic acid group, and it's very similar to this carboxylic acid group up here at the top. If this one has the proton removed at physiological pH, well, this one probably has the same thing removed at physiological pH, right? Because this is COO, this is C double bond OO. These two are the exact same. So up here at the top, it seems like people always get confused with this. COOH is C double bond OOH. Those two are the exact same representation of structure. So I could, if I wanted, get rid of this whole thing and just put CH2COO minus there again. But you need to understand that that is a carboxylic acid that is there. There is a C double bond O that's there attached to an OH. The H has been removed because it's physiological pH, and that is above the pKa value of the carboxylic acid. So there's the structure for our first acid-containing group. So let me write that over here to the side. So acid-containing. And we are going to call this amino acid aspartate. So ASPARTATE, aspartate. Now, the kick is if this is a CH2COOH group. So if we put it in a acidic environment and we put the hydrogen back onto these carboxylic acids, it goes by a different name. So that name is either aspartate if it's negative or aspartic acid if it's protonated. So either or, you've got to be careful. Aspartate, aspartic acid. They are referring to the same structure. The only difference is that one of them has the hydrogen removed and the other one has the hydrogen on it. If it has the hydrogen on it, then by definition it is the acid form, so therefore it goes by aspartic acid. Okay, so there's one of our acid-containing groups. So let's erase this and let's replace it with something else. So we know that there's another one. It's going to, not surprisingly, be very similar to the one before. This one, well, it just has kind of an extra carbon in it. So CH2, CH2, COO minus. Okay, so there's our second version, and this second version is called glutamate instead of aspartate. So this is glutamate, and if this is in an acidic form and it can have that hydrogen on it, well, this is going to go by glutamic acid, just like aspartic acid from above. So there's our two acid-containing amino acids. Notice they're only different by one carbon. Aspartate, glutamate, aspartic acid, or glutamic acid. Depending on the pH that you put it in, they can go by different names. At physiological pH, we're looking at aspartate and glutamates. And that's what we refer to them most of the time as. However, depending on the environment, again, These things can go by a different name because they're now protonated or deprotonated. All right, so there's our acid-containing ones. Well, if we've got acid-containing ones, then maybe could we have basic-containing ones? And the answer is yeah, you can have those basic kind of amino acid functional groups on there as well. Instead of carboxylic acids, you have amides on them though. So now let's take a look at the amide containing ones, and I'm going to write those over here. So amide containing groups. And our first amide containing group is a CH2 with a C double bond ONH2 out at the end. So there we go, CH2, C double bond ONH2. This structure, very important, because this structure is called asparagine. So this one is ASPARAGINE, asparagine. So look at the INE ending and note that that INE ending kind of goes with the word amine, right? So there's one version. The other version that I could have looks, again, very similar, but it's a CH2, CH2, C double bond ONH2. So I just sandwich another carbon in there. That one is going to be called glutamine. Notice these are very similar. Aspartate, asparagine. I add another carbon. Glutamate, glutamine. The enes should trigger amine group, and those have NH2 groups on the ends of those. Now, what are the three-letter, one-letter abbreviations for these? Okay, so asparagine, let's start down here at the bottom. Asparagine is ASN. So they kind of want to put a focus on the ene ending, and that N ending should kind of trigger nitrogen group. So ASN is what asparagine will go by. And asparagine has a one-letter abbreviation of N. A is already taken, S is already taken. The N, well, that's kind of next in line, so that's what we choose for the one letter. The glutamine. Glutamine will actually come to you as GLN. So first two letters and then N to let you know this is an amine group. So you need to focus on nitrogen there. And glutamine has a one-letter abbreviation, not of a G because that's glycine, not L because that's leucine, not N because that's asparagine. So they just pick a random letter here, and this is where the one letters get kind of funny because this is a Q of a one-letter abbreviation. So those are the three-letter and one-letter abbreviations for asparagine and glutamine. What about aspartate and glutamate? What do those go by? Well, aspartate is ASP, so first three letters, it makes sense. Well, it can't go by A because that's alanine. It can't go by S because that's serine. Can't go by P because that represents another amino acid we haven't seen yet. So they do the next letter, and that's a D. So aspartate is ASP with a D as a one-letter abbreviation. Glutamate. Well, the issue here is GLU, so that is glutamate or glutamic acid, right? And GLU, well, G is glycine, L is leucine, U they don't really want to use, and they use E instead. So there's the three-letter and one-letter abbreviations for glutamate. Now you're starting to see the problem. Now you're starting to see the more amino acids that we have, especially with the one-letter abbreviations, they tend to get a little tricky. And the reason for it is because these one-letter abbreviations tend to make sense in the beginning until we get so many of them. And because they all start to have G's in front or A's in front, we can't really use G and A every single time for a one-letter abbreviation. We have to change it up a little bit. So this is it. This is the tricky part with the one-letter abbreviations. Three-letter abbreviations pretty much are really the first three for the most part. Really no difference there. It's the one-letter abbreviations that you've got to be careful with. Okay, so there are four more that gets added on to our previous 9. So that brings our total up to what? 13. And here are 2 acid-containing groups and 2 amide-containing groups. So we'll keep trucking on. We'll keep moving on to the next batch. And stay tuned because you're almost finished. It's just one structure after the next.